So here is a reminder of long division. Do you remember setting it up like this? Now, the idea of long division was that you were going to see if you could divide certain parts of 2,748 by 13 by doing it in smaller amounts rather than doing the big amount all at once. So if we look at our 2,000s here, well, 2 doesn't divide nicely by 13. Okay? So then we go to one more digit, and if we look at the first 2 digits, those first 2 digits represent 2,700. But 27, how many 13s would there be in 27? 2. So because there's 2 13s in 27, we write a 2 above the 27. And the reason we're writing the 2 in that exact spot is because the 27 is really 2,700. And when we ask how many 13s are in 27, we're asking how many 13s are in 2,700. And we say 2, but we really are talking about hundreds here. So we write our 2 sort of in the same column that our hundreds are, because that 2 is going to represent 200 and something eventually. So when we think of it as 200, what is 2 times 13? Well, it's 26, and it's really 2,600. Probably when you learnt long division, you didn't write those extra zeros in there. You just left it blank, and that's okay. But it's kind of nice to write them there because it builds more on the understanding of what long division is, and it's really 2,600 that we're subtracting. And when we subtract 2,600, we get 148 left. Now, the process of long division is doing the same thing over and over and over again until you're done. So now that we've figured out that we're going to have something in the 200s, and we subtracted 2,600 as a result, we're left with 148. And now we do the same process with the 13 and the 148 that we did with the 13 and the 2,748. You look at your digits until you can divide something by 13. Can you see that we have to go to 2 digits to the 14 before we can do that? And how many 13s are there in 14? There's 1. Now we put that 1 in the tens column because the 14 is really 140. And if we add a 10 there, what's 10 times 13? Well, you would do 1 times 13 is 13, but really it's 10 times 13, so we can think of it as 130. Subtract once again. And now we're down to 18. How many 13s are there in 18? 1. So again, we're doing the same process. I'm just going to write, this was the first time we did the process, this was the second time we did the process, and this is the third time that we're doing the exact same process. And then 1 times 13 is 13. Subtract, and we get 5. Since 5 doesn't divide well, we have a remainder of 5. So 2,748 divided by 13 is 211 remainder 5. And that 5 would still need to be written divided by 13. So if you wanted to be exact, the exact answer for this as a mixed fraction is 211 and 5/13. Yes? You don't have to write the little 1, 2, 3, no. Okay, but I just want to show that we are doing the same thing over and over and over again. So if you can do it once, you just have to do the process again and again until you get to a point where the number no longer divides by 13, and that's going to be a remainder. So notice how we put our 2 in the hundreds column, because when we multiplied that, we got 2,600. We put our 1 in the tens column and then our final 1 in the ones column. And so there is an importance of where we put our numbers as we divide. Here's our next one, 4,212 divided by 27. Obviously, there's not any 27s in 4. But if we go to 42, how many 27s are in 42? 1. Now we put that above the 42. because this is in our hundreds column, and 1 times 27 is 27, but we're really doing 2700. And if we subtract, what do we get? $1,512. Now we look at the process again. Now we have 1,512. How many 27s in 15? We can't do that. We have to go to 151. How many 27s are there in 151? 5 or 6, right? So you could do some math off to the side. And that math off to the side, you're going to find out 5. 5 times 27 is 135. And again, since that 5 is in our tens column, it's really like 50. And we're left with 162. Again, it's not enough to look at the 16. You have to look at the 162. We found out that 5 was 135. If you add 27 to that, you actually get 162. So this one's going to be 6. And here we have a remainder of 0. So this means that 27 divides 4,212 perfectly. So now we take this idea and we apply it to algebra. Okay? In fact, that's what we do with a lot of things. Okay? We take our ideas of numbers and apply them to algebra. So we know that 1 plus 2 equals 3. We learned that 1x plus 2x equals 3x. All sorts of applications that you can do with regular numbers can be applied with algebra, and sometimes what you learn in algebra can help you with regular numbers. Ooh, now I'm getting off topic. All right, hey, let's get off topic for a bit. Now we're going to look at, can we apply the same techniques of long division to algebra? You want to divide 3x squared minus 4x plus 5. And you want to divide it by x minus 2. So this is how, oh, you wouldn't even need the brackets there. I'll put the brackets in. This is how it would start up. And in long division, you always looked at your first numbers and asked yourself, could you multiply to get close to that number? So my first number is a 3x squared. What would I multiply this by to get a 3x squared? A 3x. Does that make sense? So because I want to multiply this by a 3x, where would I write my 3x? Over which column? The second one, because that's where its like term is. So just like when we were doing hundreds, we wrote over the hundreds. Now we've got an x column. We write our 3x over the x column. Now, if I actually multiply 3x times x minus 2, what do I get? I get 3x squared, and then I get minus 6x. So it didn't match up perfectly. But when we multiply that through, what did we do as our next step in long division? We subtracted. And if we subtract here, 3x squared minus 3x squared will be 0. You don't have to write that 0. But minus 4x minus a negative 6x will be plus 2x. And there's nothing here, so that 5 would just be brought down, just like you probably originally brought down numbers when we didn't have zeros there in long division. Negative 4, subtract a negative 6. We have to make sure that we distribute our negative. And that will be one of the places where you will make the most mistakes in long division, is just adding and subtracting. Now, we start the process again. Now what's our biggest number? The 2x. Could we multiply x minus 2 by something to get a 2x? 2. Where are we going to write that? Above our constants. And 2 times x minus 2 is 2x minus 4. Again, since we're dealing with more than one thing, we'll put it in brackets so that when we subtract, here we'll get 0. What is 5 minus negative 4? 9. Can you multiply x to get 9? No. So that's your remainder. Remainder 9. And we just use long division to divide a polynomial. To give you the big picture of where this unit is going, we are going to use techniques that we learn with long division and with algebra to learn how to factor bigger things. Like you can factor quadratics now. You're probably getting pretty good at it. But what about cubic functions? What about quartic, quintic, things x to the 5? Can you factor those? Yes. And we're going to learn how to do that. Okay, this one is for you to try. You try the second one. 2x cubed minus x squared minus 2x plus 1. So when we look at our biggest term, which is the 2x cubed, what can we multiply to get a 2x cubed? 2x squared. We make sure we write that over our x squared column. And then we multiply that 2x by this whole thing, and we'll get 2x cubed. And 2x squared times 1 is plus 2x squared. Put this in brackets and subtract. We will get 0. Minus x squared minus 2x squared will give us minus 3x squared. We still have a minus 2x and a plus 1. Now we repeat the process. Now our biggest term is minus 3x squared. What could we multiply this by to get a minus 3x squared? A minus 3x. Minus 3x times x will be minus 3x squared. When we distribute, minus 3x times a positive 1 will be minus 3x. Put brackets around that and subtract. We get 0 here. Minus 2 minus the negative 3 will be plus 1. And 1 minus nothing will be plus 1. How do we get an x? Plus 1. 1 times x is x. 1 times 1 is 1. Put brackets around that and subtract. Everything goes away, and there is no remainder. What this means is you could factor this. So if you happen to get something that divides without any remainder, well, we can write, and I'll just write it down here below, what this means. It means that 2x cubed minus x squared minus 2x plus 1 is equal to x plus 1 times 2x squared minus 3x plus 1. We started to factor it. In fact, we could factor it even more. Because this is a quadratic, and you already know how to factor that. How do I get 2x squared? What has to be first? 2x and x. Well, how do I get 1? 1 and 1. They would both have to be negative in order to get the 3x, and now we've factored this thing completely. So cubics can have 3 factors. But the question is if you had this to start with, how do I get x plus 1 as one of my factors? Because I need to know one of them in order to do long division to find out what's left. And that's another thing that we're going to develop in this unit. All of those strategies to figure these things out.